only going to do the first part of this problem. And I'm just going to tell you right now, there is a way to do this problem for the second part. There's a way to do the second part of this problem that will guarantee you the right answer by plugging in every single number and brute forcing your way through it. And there's a way to do the second part of this problem by actually engaging your algebra skills and canceling terms by using variables first before plugging in numbers. So, with this particular problem, if you are able to solve this problem, the second part here, in the smart algebra way, I will assign you 4 bonus points on the exam. I will not be giving hints. Just putting that out there. So, the height is 2 meters. The way, by the way, I'm going to solve this problem is I'm going to use the non-clever way of just putting in numbers everywhere I see them as soon as I can. So the height is, the radius is 0.5 meters. And the mass is 2 kilograms. And let's get the speed at the bottom. So I have all gravity energy getting converted into kinetic and rotational kinetic energy. So we have mgh equals 1/2 mv squared plus 1/2 I omega squared, because we're dealing with rotational energy. So we have 2 times 10 times our height, which is 2 for this first part, equals 1/2 times 2 times v squared plus 1/2. Now it's a hollow sphere, and I will be giving you those on the test. It's 2/3 mr squared. So that's going to be 2/3 times 2 times 0.5 squared. That's the I part. And the omega part is going to be, well, it's squared, so it's v squared over r squared, which is 0.5 squared. So I'm going to get 40 here equals 1/2 times 2, v squared, plus 1/2, and I'm just going to do my math here. So 2 times 2 times 0.5 squared divided by 3. Let's smash all those numbers together. So that's going to be 0.5 times 0.5 times 4 divided by 3. So I'm getting 1/2 times, sorry, this is a little weird. I seem to have written this in a way that I don't like. So let me just double check. Right here, I'm going to just write 1/2 here, and then I'm going to go ahead and figure out what's in this parentheses. And when I do that, that's going to be 2 divided by 3 times 2 times 0.5 squared. And that's going to give me 0.3333 v squared divided by, when I take 0.5 squared, that's going to be 0.25. Continuing, 40 equals v squared plus 1/2 times 0.333333. is 0.1667 v squared divided by 0.25. And we're going to continue. 40 equals v squared plus 0.6667 v squared. So I'm getting 40 equals 1 plus 0.6667 v squared. When I go ahead and get v squared, that ends up being 24. And v itself ends up being 4.899 meters per second. That is only this first part here. I'm going to let you solve the second part. Now, like I said, there is a way for you to come up with a general formula for v in terms of h and g alone. And you can use that general formula to solve both parts of this problem. If you are able to do that on the exam, I will not only give you full credit for the problem, but I will assign you 4 extra bonus points. All right, so that's part 5.